So as I'm looking at this AI just means any term in the geometric sequence. So if I were to go ahead and write that out, that would be A1 plus A1 times R plus A1 times R squared, going all the way up to A1 times R to the N. And that actually has a sum we can find. Now that only happens when it's finite, which means I have an ending point. That is A1 times 1 minus R to the N over 1 minus R. Now I do want to spend a little bit more time talking about this sigma notation because there's a couple of other different ways I can write this. I could also write this as sigma as k goes to 0 of A1 times R to the k power up to n. And if you see, if you're using the summation notation, the first term, A1, happens when k is equal to 0. So that just gives you, that would equal A1. Now, the second term, or A sub 2, right? That would just equal to, in the formula, would be A1 times R to the 1. Again, this is the first term. This whole piece is the second term. Now if I do it one more time, the third term would be A1R squared. And this is what happens as you are plugging in k. You're replacing k with starting from 0, going up to 1. It means exactly the same thing. And again, this is just the same thing. You keep going all the way up to A1 times R to the N. So let's go ahead and use this formula. So let's say I have the sequence 2, 6, 18, all the way up to 2 times 3 to the 8th power. Now we need a couple of different things with this. In order to use the formula, our sum is equal to A1 times 1 minus R to the N all over 1 minus R. So we need to find A1, and A1 is just the first term, which is 2. We need to find R, and I find R by just taking 6 divided by 2, so that is equal to 3. And the last thing I need to do is find N. So to find N, let's go back in a second and look at the explicit formula. Our explicit formula says that A to the N, which means that last term, is equal to A times R to the N minus 1. So what I do with this is I go ahead and take, since I know that last term is to the N minus 1 power, so I have to go ahead and solve for that. So that tells me that N minus 1 is equal to 8. So that means N is equal to 9. So let's go ahead and write that all in the summation formula. Remember, in my summation formula, I am going from k is equal to 1 to n, which we just found, of 9. My ratio is 3 raised to the n minus 1 power times the first term. And the first term was 2. Remember, we found the ratio up here, so all I need to do is put that 2 is inside there. And I know all of that is equal to my formula A1, 1 minus R to the N over 1 minus R. So I go ahead and plug that in, and I get 2 times 1 minus 3 to the 9th, all over 1 minus 3. And just plug that into your calculator. You'll get that is 19,682. So I want to do the same thing with this. I want to go ahead and find the sum. So just go ahead, we're going to label everything. And this just means this is term 1, and this is the second term, the third term, the fourth term, and the fifth term. Now, you can go ahead and add that all up by hand, but I do want to go ahead and use a formula. I want it written in summation notation. So we know the sum goes from k is equal to 1 to n. And inside here is the explicit formula. Which is just the first term, a1, so that is 4. Now the next thing we need to do is we need to find the common ratio. So the common ratio is just going to equal negative 4/3 divided by 4, or negative 4 over 3 times 1 over 4. So that common ratio in this case is negative 1/3. So then I take that common ratio, negative 1/3, and that is to the n minus 1 power. So again, I want to find the sum of this, and the sum is equal to a1, 1 minus the ratio to the nth power, all over 1 minus r. So that just gives us 4 times 1 minus negative 1/3 to the 5th power. Do the inside of this bracket first. All divided by 4/3. So when you are doing this, this will give you 4 times 1 plus 1 over 243, all divided by 4/3, which is equal to 244 over 81. And you can go ahead and check that just by adding those 5 pieces together. All right, so we can also do this for certain cases when you have an infinite geometric series. Now, remember, this is just the explicit term. You could also write that as AI, as I had done before. When you have this infinite series, you have to make sure the absolute value of r has to be less than 1. Another way of saying that is that r must be between negative 1 and 1. It must be a fraction. Now, when that is true, and this must be true, then the summation from when k goes from 1 to infinity of the geometric series is just a1 divided by 1 minus r. And again, you absolutely have to have this condition first. This must be true. That only happens when the absolute value of r is less than 1, or another way of saying that is r is between negative 1 and 0. So let's go ahead and look at one of these. So if I have the series 2, 1, 1/2, 1/4, 1/8, going on forever. In order to find this, we need a couple of different things. First, we have to find r, and r is just equal to 1 over 2. So that meets our conditions. And then I go ahead and write this, and that's all I need. So now that I know that the sum, as k goes from 1 to infinity, of 2 times 1/2 to the k minus 1 power. And again, where did I get that formula from? The first term is 2, so that is where this is. My ratio is 1/2. So I know that as it goes to infinity, if I add it all up forever, that will equal the formula of a1, which is 2, over 1 minus my ratio, which is 1 minus 1/2, or 2 over 1/2. 2 over 1/2 is the same thing as saying 2 divided by 1/2, or 2 times 2. So that whole sum, if you add it forever, will converge at 4. And that's what we would say. We would say the series will converge at 4. So we'll look at another one. So let's say I have another piece with this, and it's 1 over 48, 1 over 16, 3 over 16, 9 over 16. And I want to know if we can find the sum of this infinite sequence. So I start off with saying a1 is equal to 1 over 48. Step 2 is to find the ratio. So the ratio here is 1 over 16 divided by 1 over 48, or 1 over 16 times 48 over 1, and you will see that actually equals 3, right? So therefore, because that is 3, this series will diverge, and it does not have a sum.